Hello, this is Mr. O again, and today's notes will be called distance on the coordinate plane. So let's write this down. Distance on the coordinate plane. So today's notes are called distance on the coordinate plane. So if we need to find the distance, now let's recall a few things real quick, right? So first thing first, let's say we have 2 points. One of the points, let's call it point A for some reason. Let's say it has these coordinates. 2, comma 3. Here's what we need to remember, right? So this is a review, there's nothing new, but A with coordinates 2, comma 3 means if you go on the x-axis first, because first number tells you how far to go sideways, right? Let's say you go to 1, 2, all right, let's say, and then second number is could tell you how far to go on the y-axis, 3, which means if you go 2 to the side, 1, 2, and goes 3 up, this is where this point would be, right? Again, in geometry and algebra, all of the points have their names, so we'll call this point A. Yeah. The next thing which we will do, we will put another point, and this one will have coordinates, let's say 6, right? So let's call this point B. So let's say point B has coordinates 6, comma 3. This basically means all we have to do, we go 6 spaces to the side. We always go from a center. So from a center I go 1, 2, 3, 4, 5, 6. See, I'm counting spaces. 6 spaces to the side, 3 up. 1, 2, 3. And this is where my other point will be. So again, 6 spaces to the side, 3 up, and that's where I put my second point. So now, this is my point B. Let me write down here, point B. Okay, so now what we want to find today, right? So we want to find distance between A and B. And I think it's really easy if I say find the distance between A and B. Okay, all we have to do, right, to find distance between A and B is just to see how many spaces is been between. Again, I'm always counting spaces. So what I will do, I say, okay, if I want to get from A to B, I go 1, 2, 3, 4. See, there are 4 spaces in between. So the distance between A and B is 4. So in algebra, we will write AB, right, like equal 4. That's basically what I just wrote as. The distance between 2 points A and B is equal 4, right? 4 spaces. Easy enough? Okay. Actually, just to be sure, maybe I'll even write word distance, so you know what this thing means. So distance between AB, so distance AB is equal 4. Now, next thing which I'll do, let's try classwork. So this was example, this was example number 1. So let's do that example number 1, and let's go on the next page. And on the next page, we will try classwork. Okay. So going on the next page. We done with here? Awesome. All right. Classwork number 1. Classwork number 1. Okay. Question number 1 said, find the distance. Same as we just did sec again. Again, let me grab one of these things. Let's say, and let's talk about how we got to do it. Still, here's what we do. Let's say that we have 2 points. This time we'll call one point, we'll have name K, right? And K would be 2 to the side and 1 up, right? And let's say we have another point, and another point will have name like L, and L is still 2 to the side, but this time it would be 9 up. Question is, find the distance between. So how much is the distance KL? I'll put the question. All right, so how far between these 2 points? So you have to graph them on the plane, and find the distance between these 2 guys. All right. So let's see. Could you do it? All right. Let's move on. So now example number 2. Okay. Example number 2 will still say find the distance, but it will get significantly more difficult in a second. All right. As you recall, what we just done second ago, we were continuously finding, let's say, how many spaces between 2 points. But what if, let's say I have one point in here, okay, so this first point I just drew has coordinates actually in here, and another point would be, let's say, in here, in here. Okay, I think now. So just so we have them in the same place, let me write it up. So first point, I wrote, let's call first point, we didn't use letter R. So letter R has coordinates, 1 to the side and 2 up, right? So this is letter R, right? So this is letter R, and this letter in here, but if we'll call it with, whatever, let's use letter V. I think letter V is pretty cool. Alright, so would be letter V. Okay, so we have R and V in here. Alright, and let's say I want to find distance between these two. Again, let's write down their coordinates first. So R was, as you see, 1 to the side and 2 up. So 1 to the side and 2 up. As you see, letter V was 2, 4 to the side, right? So V was 4 to the side and 1, 2, 3, 4, 5, 6 spaces up, 6 up. Now, with that said and done, I still want to find the distance. But here's the problem. Look, if I even connect, let me connect these two with a straight line. When I connect it with a straight line, look what's happening. I don't know how many spaces it is. See, there's a little problem. In here, it kind of looks like a whole space, but maybe there is a little bit of it, a little bit here, maybe even a little bit less. See, it's sort of, the line is sideways, right? It's not straight. So I cannot count how many spaces in between. So there has to be another way. And as you probably figure, right, Mr. O is bugging you for the last couple days, right? Where's that Pythagorean theorem? So you're like, maybe I can use it somehow in here. And the answer is yes. Yes, you absolutely can. You absolutely should. So here's how this thing works. Right. So first thing first, right? Even though it's just one straight line, your first job is make this thing into a triangle. So look what I'm gonna do right now. All right, let's see if I can use this. All right, so maybe it's a little bit too big. All right. Okay, maybe I'll use this. Yeah. So I'll make this thing into a triangle. See, with this dashed line, I'm sort of showing you what I'm doing. See, like, you have to make it into a right triangle. Right? Not just triangle, it's a right triangle. So I made it into a right triangle. Next thing which I do, I say, look, can I in here easily count how many spaces I have on the grid, right? Let's see. So I'll say in here 1, 2, 3. See, I can definitely count how long this side is. It's 1, 2, 3 spaces long. How about if you write it down? So this side is 3 spaces long. Boom. Alright, so this is, see, I couldn't figure out how long is the side that I really need to find in my answer, but I could easily say that this short side is 3. Now count this one. 1, 2, 3, 4. See how it's 4 spaces long? So let me write it up. This is 4 spaces long, right? This is 4. Okay, so far is good. So next thing which I do, I say, okay, if I know this is 3, this is 4, right? Because I just counted spaces. Can I now just simply figure out this side? And I say yes, because look, all I have to do is just use Pythagorean theorem. So here's what I do. 3 times 3 is equal to 9. Again, if you're not sure why I'm doing this, because I'm trying to use Pythagorean theorem to figure out how long this side is. And in order to do it, I will multiply this by itself, I multiply this side by itself, I add them together, and I'll find the square root, and I'll know the answer. So that's my plan. So I'm just doing this. 3 times 3 is 9. 4 times 4 is equal to 16. Next step, obviously, as you recall, is just take these two guys and add them together. So 9 plus 16 is equal to 0.5. Right, so now we're done with this step. And the last but not least is to find the square root of 25. So square root of 25, right? Square root of, in this case, 25, as you probably already know, is equal 5. Boom. Which means I just found out how long the side is, right? So now I can put in here number 5. Boom. I just found it. The side that was missing at first and I couldn't exactly know how many spaces, now I know. even though this thing is sideways, but the answer is 5, right? Because when I did my Pythagorean theorem thing, I found out that the answer is 5. I'll even write it on the side. Answer, right? Answer. Okay. 5, answer. It's 5, right? It's 5 units long, so distance is 5. Okay, maybe I can write this. Okay, distance. Okay, distance is 5. Boom. Awesome. So we just found how long that RV is. Another way to write this, because I R distance RV is equal 5. Good. All right. Let's move on to the next page. Now we're gonna try classwork number 2. Classwork number 2. Again, as always, it'll say find the distance. All right. Now, so this time let's pull this. Okay. Obviously, we'll do this thing on the grid in a second. All right. So let's say we have 2 points. This time I'll use point C and D. So C, and I'll use in a second point D. And let's say C has coordinates, right? Let's say C has coordinates. What do we want? How about we say it's 0 to the side, right? So don't go to side, 0 to the side, but we will go. Let's go -1. All right, so 0 to the side, -1. So your job will be to graph this point, and as you probably know, it'll be somewhere in here, right? See where what point they're showing right now. And so next point which we'll use. Next point we will use would be, how about it'll say point CD. All right, so D will go 6 to the side, and we will go how many up? Actually, how about we'll go not up, we'll go down. So we will go this time -9. So now big question becomes, so if you have these 2 points, right? All right, so yes, if you have these 2 points, can you find distance between them? So what's the distance? C, D question, right? So again, your job will be, you have to put the points on the coordinate grid. You will have to make a triangle. You will have to count spaces on shorter sides. You will have to then use Pythagorean theorem to find the longest side, right? Don't forget to take a square root of it. And I think that's all you'll have to do in here. Let's see if you can actually do it. Okay, so my guess is, by now most of you are done. In case if you still slightly got stuck, here is the quick review what we learned today. So first we put points on the coordinate plane. 0, -1 meant don't go to the side, go 1 down. That's where point C had to be, right? That's my point C. Next thing, D6 -9 meant go 1, 2, 3, 4, 5, 6 spaces from the center to the side, 6 to the side, and 9 down. So that's where point D was, right? Point D. Next thing what you had to do. Next thing was you connect them together with a straight line. Connect with a straight line. Next thing what you do. Now let's make a triangle. I know some of you will say, but doesn't matter where you do it, on the top or the bottom. Honestly, answer is no. How about if just for the sake of doing it, I'll make my triangle right in here. Look. Oops. All right. So I'll put my triangle right in here. All right, now, once I did this triangle thing, the next step is I obviously had to count space. I did 1, 2, 3, 4, 5, 6. So I find out, oh, look, this side was 6, right? So this number is 6. So I'll check, so that's 6. All right, so that's 6. Now, this one, 1, 2, 3, 4, 5, 6, 7, 8. So this was 8. So I wrote 8. Now, my job is, though, to find how long this side is. And for this thing, I use the Pythagorean theorem. So let me make some space in here, and I'll just do this thing in 1 second. So first thing to do with Pythagorean, we obviously multiply couple numbers by themselves. So 6 times 6 equals 36. Now 8 times 8 is equal 64. Now next step is you add them together. So when I add 36 plus 64, 36 plus 64, I'm getting 100. Now once I got 100, Next thing, all I have to do, just take a square root. So which number multiplied by itself is 100? Okay, and the answer is correct. So, like in this case, square root of 100 is equal, square root of 100 is equal 10, right? So, and because square root of 100 is equal 10, we just found that this missing side, right, the side which is that we want to know distance for, is equal 10. So when we have to write our answer will look like this. Answer, we'll say distance CD, right, equal 10. Boom. And this is all we have to do. All right, very good.